So this video will help you with IXL activity J17 rate of change graphs. So let's look. I've printed off a page from one of the IXLs, and I'm hopeful that this will be useful as you are working this activity. So first, let's read the problem. It says Mrs. McConnell hosts an annual art contest for kids, and she keeps a record of the number of entries each year. So let's look here first at the actual graph. So as we did on the previous lessons, you can get a lot of information as you're looking at the labels. On the x-axis, it will tell us the year, and then on the y-axis, that will tell us the number of entries. So let's go back to where it says she hosts an annual art contest for kids and she keeps a record of the number of entries each year. So we've identified the graph, we've identified what is along the y-axis, which is the number of entries, what's along the x-axis, which is the year. Now let's look at the problem again. According to the graph, what was the rate of change, and remember that's the title of the actual assignment, is the rate of change between 2014 and 2015. So a couple of items here. We've identified rate of change, but what exactly does that mean and how do we calculate it? So rate of change is very simply this, and I'm going to write rate of change here. And now it's pretty simple. The numerator represents the change in value. Okay, so that's the change in value. The denominator is the change in time. And just like we've done on previous lessons, once you have the formula, it is truly just a matter of plugging in the appropriate information. So let's look. If the rate of change is the change in value, so what is the change in value from 2014 to 2015? Well, the change in value, if you look at the number of entries, so in 2014, it was 16, so the rate of change would be 16, and then it was 22. So to go from 16 to 22 is a change in value of 6. I hope you can see that on the graph. So we went from 16 to 18 to 20 to 22. That's an increase of 6. So I write 6. I'll move it over a little bit. So I'll write 6 as my numerator. So the change in time is now just how many years are we talking about? We started in 2014 to 2015. So the change in time is just 1 year. So I put that as my denominator. So in this case, the rate of change is the change in value, which is 6 entries in 1 year. And we know 6 over 1 would be simplified as 6. So when it's asking us to answer the question, what was the rate of change between 2014 and 2015? The rate of change in entries per year is 6. And that makes total sense if you look at it again. In the span of 1 year, we increased 6 entries. So again, that will help with IXL J17. Let's look at one more, and it's very similar. I'm going to write again. We have change in value is the numerator, and then change in time is the denominator, and we know all of that is the rate of change. So now let's look at the graph. So it's set up the same way. We have the time, the change in time here, the value is here. So let's look at the question. It says, according to the graph, what was the rate of change between 2011 and 2013? So I'm going to circle 2011 and 2013. So the change in value, did we change in value at all? We started with 38 in 2011, and yes, it went way up in 2012, but then by the time we got back to 2013, we were back to the same level. We were back to 38. So The initial value was 38 in 2011. The new value was 38. So the change was actually 0. So the change as a number would be 0. And then the change in time was 2 years. But we have 0 divided by 2. There was no change. Quite literally, we had the exact same amount in 2011 as we did in 2013. So for this, there was no actual change. So your answer would be 0 kilograms per year. And all we had to do was we had to first find the value, find the change in value. This was our value of 38 in 2011. Our value was also 38 in 2013. Our change in time is 2 years. We had 2011 to 2013. So once we set that up, we do a division problem. Our answer is 0, and we're good to go. So again, that'll help with IXL J17.